This is section 2.5 called Implicit Differentiation. And what that means is that you're taking derivatives implicitly, which is the opposite of explicitly. Normally we have y by itself. It's y equals, the equation's on the other side. You hit both sides with the derivative. But here, y is not by itself. It's a y squared. It's got an x to the third next to it. And of course, a lot of people are like, well, why don't you just get it by itself? And I could, because number one is an easy problem. I'm not going to start you guys off with a tough one, but there are some problems where you maybe can't get y by itself. It's either difficult or in some cases impossible. Like this. So it's important to know what to do in case you cannot isolate y. And so we take the derivative implicitly. All right, back to easy number one. All right, when we do implicit differentiation, we basically just plow straight through from left to right, taking derivatives as we go. So the derivative of x to the third is 3x squared, plus the derivative of y squared is 2y to the first, or just 2y. But wait, that's the wrong letter. It says find dy dx. And that means only x's are the correct letter. Anything other than an x, like a y or a z or a q or anything else, is the wrong letter. And you need to do what I call the forgiveness parentheses. This is not the mathematical term. Actually, this is a chain rule. Here's what I think. Okay, I know. It was a y. It was supposed to be an x. All right, you're forgiven. Move on. Equals. And of course, the derivative of a 5 is 0. Okay, back to this weird thing I just did. The reason that you need the dy dx on there is because when you're taking the derivative, let's say of x to the third, it is 3x squared, but there is a chain rule. Does the x have a derivative? Yeah, it does. What is it? Well, it's times 1. All right, but you don't see it. Does the y have a derivative after you do the 2y part from the y squared? Does the y have a derivative? Yeah, it does. It's dy dx. So really that forgiveness parentheses, as I like to call it, is really a chain rule, is what it truly is. But regardless, you got dy dx sitting there. The directions say find dy dx. Well, there it is. Let's get it by itself. A little algebra 1 will do the trick. I'm going to subtract 3x squared from both sides and divide both sides by 2y. So that'll simply be negative 3x squared over 2y. And for the very first time, the y's have gained their full civil rights. They are allowed to be in the answer as well as just the x's. The x's have dominated for all of chapter 1 and chapter 2. Now finally we have a nice, diverse mixture of x's and y's living harmoniously together in the derivative answer. And that is totally okay. In fact, you know what's okay with me? Is that we got the answer correct. I love being correct. It sure beats the alternative. Oh, that is so nice. All right, let's try another. All right, find the derivative of y with respect to x, dy dx. And x gets the respect. It's the correct letter. Everything else is the wrong letter. All right, what's the derivative of 3x squared y? Oh, I'm so sad that you asked, because that is, you guessed it, it's a product rule. U prime v plus uv prime. I think I'm going to call the u the 3x squared, and the v will be the y. So u prime v is going to be 6x, and then just v, which is just the y, plus u, which is 3x squared, v prime, the derivative of y, of course, is 1. Oh, that's the wrong letter, dy dx. And of course, some people are quick to point out, whoa, how come you didn't put a dy dx on this y? It was the wrong letter. I'm like, yeah, but you didn't take the derivative there. It was u prime v, and it was just a v. It was just a y walking down the street, minding its own business. We're not taking the derivative of it. It's allowed to be itself. But when you do the uv prime, that's when you need it. So hopefully that helps out. All right, plus. The derivative here, we have to use the power rule. So 3 halves times 8, that would be 12. 24 halves, that's 12. Y to the go down by a power, so that'd be y to the 1 half. Oh, but it's still the wrong letter, dy dx. The derivative of minus 5 is 0. Now we have a chain rule. This says everything. 3 times the 1 in front will be 3. Stuff, just copy it. To the go down by a power, so that's going to be to the second, times a chain rule. Does this have a derivative? It certainly does, times 8x. And I'm out of room, so I'll just go below. The derivative of y squared is 2y. Oh, dy dx. It's the wrong letter. Okay. The directions say find dy dx. Unfortunately, there are 3 of them, and they're even on different sides of the equal sign, so I have to get them all on the same side. So what I'm going to do is anybody who has a dy dx, we're going to keep you on the left, or get you on the left. Any part of this problem that does not have a dy dx is going to the right. So I need to subtract away 2y dy dx from both sides. That'll cancel this out. And then over on the far left, that 6xy does not have a dy dx, so it needs to go to the right. So I'm going to subtract it off. It'll cancel itself away. And it's also subtracted over here on the right. Since everything on the left-hand side now has a dy dx, everybody's doing it, everybody's got one. That means you can factor it out. That's the whole point of getting them all together, is so you can factor. Now there's only one dy dx, and we know where it is. It doesn't matter what order I write these in. 3x squared plus 12y to the half, or 12 rad y if you prefer, minus 2y. As long as the negative is in front of the 2y, you're fine. All right, on the other side, I'm going to combine to make this look a little nicer. So that's 24x times the quantity squared minus 6xy. All right, now all I have to do is get dy dx by itself, which means I'm just going to divide both sides by this parentheses, and here's my final answer. Oh, look at that answer. That's awesome. This is awesome, not beautiful. It's pretty ugly, actually, but it's so right. How right, you ask? How about that? Yeah. Hey, gone are the days of good-looking answers, man. That ship has sailed. You're not going to get an answer like 5 anymore. You're going to get an answer with x's and y's all mixed together with a bunch of crazy stuff. As long as you can get past the trauma of seeing that and you start trusting yourself, just go slowly, take your time. If you do this homework slowly, you'll do it once. If you try to rush through, you're going to end up doing it multiple times because you're going to have mistakes everywhere. So slow and steady wins this race. All right, let's try number 3. We're only going to do 4 examples each day. Here's a trig-flavored problem. All right. Find dy dx. All right, well, I can see that it's going to be impossible to get y by itself unless I want to deal with inverse cosine. No thanks. So I'm just going to plow through, straight through from left to right, taking derivatives implicitly. The derivative of sine of x is cosine of x. The derivative of cosine of something is negative sine of that item. So negative sine of y. Oop, I said y. That's the wrong letter. dy dx. All right, right-hand side. The derivative of 5x squared is 10x. And the derivative of 2y to the third is plus 6y squared. Got to use the power rule. Oh, but that's the wrong letter. dy dx. It's a chain rule. It's a forgiveness parentheses. It's something you have to have. All right, let's see what to do. I'm going to subtract 6y squared from both sides, with the dy dx on it, of course. That'll cancel this out. So all the dy dx's are on the left. And then in red, I'm going to subtract cosine of x from both sides, which of course will knock this out. And now I have this. And finally, to free up the dy dx, obviously I factored it out front. I think you guys figured that out. I'm going to divide both sides by the parentheses that's there on the left. This, of course, will cancel, and this is my derivative. All right. Hey, let's check it out. Let's see if we got it right. This is always the exciting, dramatic moment for me. Oh, yeah. Ooh, it looks different. But you know what? It's not. We're right. If you look at the answer I had previously and you look at my new answer, they're the same thing. In fact, I like this better. That's why it's got stars by it. All I did is I took my answer down there in the black box, and I multiplied the numerator and denominator both by -1. Because that way, instead of 3 negative signs, I only have 1 minus sign. They're both equally correct. You're probably going to see the top one in the back of the book, just because they don't like to have as many negatives. And the parentheses in my answer is now optional, as long as you can tell that the minus 6y squared in the denominator is not poking out to the side. That parentheses does not have to be there. If you were to type it into the calculator, however, you would have to have it. So, all right. So the moral of the story here is if you look in the back of the book or you look online or wherever to check an answer, if all 4 of the signs are backwards, that's the same answer. If you have 2 or 3 of them backwards, then you get some negative sign error somewhere. But if all of them are backwards, that's the same thing as somebody coming through and multiplying everything by -1, numerator and denominator, which is fine. So both answers are good. All right, one more problem. I'm going to split section 2.5 in half. We'll do, like I mentioned, 4 problems each day. So this next one is it for day 1. Find dy dx. All right, left-hand side, there's a 1 in front. We're going to use the power rule. So we have 8 times the quantity 5x minus 3 to the 7th, down by a power. Is there a chain rule? Oh yeah, times 5. Okay, that's cool. Right-hand side. What's the derivative of this? Well, again, power rule, 4 times 12, that's 48. Y to the go down by a power, 3rd power. All right. Find dy dx, the directions say. Oh dear, I don't have one. Yeah, because you forgot that the y is the wrong letter. You need a dy dx then? Yeah. Okay. Now we're ready to rock and roll. Let's divide both sides by 48y cubed. Same thing over there. Dy dx is left by itself on the right. 5 times 8 is 40, but you know what? I'm going to cancel instead. Let's keep the numbers small. So the answer is 5, quantity 5x minus 3 to the 7th, over 6y cubed. And I'm ready for the reveal. All right, never a doubt. Okay, that's it for day 1 of section 2.5. So just to summarize, you're going to plow straight through from left to right, especially if it's tough to get the y by itself. I mean, here in number 4, I could have divided by 12 and taken a 4th root. That doesn't sound too exciting. But certain times you can't get y by itself. So you plow through from left to right, and whenever you come to anything other than an x, it's the wrong letter, and you have to take what I call a forgiveness parentheses, which is actually a chain rule, dy dx. Then you're good to go. You're forgiven. All right, so that's day 1. Problems 5 through 8 we will tackle in the next lesson. See you guys then.